Recording in progress. So welcome to lecture 3. Today we are going to be dealing with environment lighting. So this will be project 5. You guys will be doing a day scene, interior or exterior, your choice. And then you will be doing a night scene. The night scene is opposite environment of the day. So if you did the interior day, you need to do the exterior night. If you did the interior day, exterior night. If you did the exterior day, you need to do the interior night. Does that make sense? Opposite environment, opposite time of day. All right, project 5 becomes project 6 for materials. So kind of laying out the roadmap here. And then project 6, one of your environments, one environment only, becomes project 7. Which is texturing. Now, texturing does not mean every single object gets textured. If you're only going to be doing 2 things in Painter, the idea is you only put textures on objects that need it. We'll define that later on when we get into maps. Because just because something is a solid color doesn't mean you need a map. It's got to meet certain criteria in order for it to need a texture map or any one of the basic maps that we have, which are going to be color maps, spec maps. Sometimes in Substance and other programs, they're called metallic roughness, and then also finally bump. You guys have probably been doing normal maps, but we're going to be doing bump maps with Arnold because it's very simple, easy to understand what the concept is, what it's doing, and how you control different parts of the material with a single map. All right, so kind of a brief overview, brief roadmap from here until the end of class. So there's a lot to do, and we'll get it done. Anybody have any questions so far? Make sense? Discussions, panic, regret? Okay.
Professor, I have a quick question.
Yep, go ahead.
So this is still week 2, right?
This is correct.
Because aren't we missing like a week of assignments there? Because if we've been doing 1 lesson per class, we usually have 3 classes per week. That would finish sometime next week, and we would still have an additional week after that. You understand my?
Yep, I do. So let me kind of clarify that. So project 5 is 1 lecture, 1 lab. Project 6 is 2 lectures, 2 labs. Project 7 is 4 lectures and 4 labs, 3.5 lectures actually. Okay, but 4 lectures, 4 labs, because they're broken down into parts. So they're easily digestible. For instance, project 6, which is materials, we break that down into reflectivity, which includes metal, And then the second part is glass, which is transparent objects. Okay, make you feel a little better?
Yes.
Okay, good. Yeah, actually, very good question. Because we're going to spend a lot more time on these things because there's a lot to understand about what goes into making something reflective or transparent like glass. And then we get into the basic maps. Not only do we get into the basic maps, we go into taking a file off of the internet, making it repeatable in Photoshop so it's seamless. So we can repeat it without or with minimal notice that it is a repeating texture. We get into one lecture, one lab on Substance Painter. We get into using layered texturing in Maya. Layered texturing also includes things like opacity maps, projections, which are like decals or stickers. And then we get into displacements, kind of wrapping things up, displacements being an actual form of changing the geometry at render time, unlike a bump map or a normal map, which is really just a fake. All right, so very good question there, Julio. Thank you. Any others before we head on? Good. All right, so next week, office hours will be Tuesdays, Thursdays again from 10 to 4. Frank or Aria will be doing the open lab in Zoom on Thursdays. That'll be 1 to 5 Eastern Standard Time. That's for online and campus students. Optional, of course. So today we're going to start with interior lighting, what the camera sees, how we interpret camera exposure, because now we talked about light intensity versus exposure and lights. Now we're going to get into interpreting what cameras actually record and transferring that into practical CG information. Exterior lighting, a little bit different than interior. Interior, we have walls, we have windows, we have doors, we have things called portals, which let light in. Outside, you're basically unrestricted, unless of course you're standing under some kind of overhang. Time of day, shadow length, very important. Today, we are going to be switching from adding color in the light using the color attribute to turning on color temperature in the lights. Color temperature is going to give us a more realistic, natural looking color to the light. One thing you'll notice about color temperature is that the light color is not as saturated as you think. Go outside, we see warm light, mostly from the sun. Come inside, we see mostly warm light from these artificial lights. As you know, the sun kind of lowers in the sky, the color of the sky changes, the light becomes a little cooler. So there's a lot going on there between nighttime, daytime. And color temperature is a good way to help indicate to your audience or your viewer exactly what's going on. We're also going to be introducing dome lights, portal lights, which work together. So portal lights work inside the dome. They really don't have any attributes of their own. They are mostly kind of like an extension of the dome light. We use those for interiors, portal lights, that is. So for example, if we were doing this room that we're in here at Full Sail, we've got a couple of doors, we've got little holes in the doors, we've got windows alongside the door, we've got a big oval shaped window in the middle of a wall. Okay, all of that would be a perfect case to use a portal light, because we would have a big dome light with an image in it outside that would provide some light and color and basically a virtual environment outside that we could see. But instead of calculating 360 degrees of light, it makes sense to just funnel it through smaller openings. It's a lot more efficient, especially when we go to render. We'll also get into mesh lights. Mesh lights allow us to convert ordinary geometry into light emitting shapes. Light emitting shapes basically have the same properties, the same light attributes as normal lights. And then nighttime versus day, and then just making sure you have color management turned on to linearize your colors. Basically, when a nice smooth transition between one color and another, or between, light intensities. All right. Any questions before we get started? Out there in Zoomosphere, any questions?
No, sir.
Okay, thanks, Julio. AJ, Gaetano, any questions? Go ahead, Gaetano, you have a question? You can unmute yourself, just hit the space bar.
Yeah, I do have a question, but so for the assignment I turned in, it just said I didn't denoise, but I had my denoiser on, so I was wondering if there's like another option for denoising.
We'll have to talk about that offline. That doesn't really relate to what we're doing.
Yeah, I know. So I was like, oh, maybe I shouldn't just said yes.
Yeah, we can address it real quick in between either that or when we start up the second half.
All right, thank you.
Okay. All right. So let's take a look at exposure, what the camera sees. All right, so I've got two environments here. One on the left, I took the photo with a manual digital single lens reflex camera, DSLR. Okay, manual everything, manual exposure, manual color balance, manual ASA, manual focus, everything was done manually. And my goal was to set it up to capture what I saw outside the window and then what I saw in the room. And I did the same thing with my phone on the right. And the results are fairly similar. All right, so over here, I adjusted the camera so it looked natural outside the window. Inside here, it looks too dark or underexposed. Looks like it needs more light. And then what I decided to do was set the camera up so that when I took the picture inside the environment, it looked natural. But outside, I got the opposite. I got overexposed. Now, the reason this is a big deal is because a lot of times you will find reference on the internet that will have the environment looking really good inside. And if you look outside the windows, everything is kind of blown out. Really super white, really hard to see. That is a natural phenomenon of what cameras do. Our eyes, unlike a camera, can adjust almost instantaneously between a dark environment in here, and then if I look outside, I see something that looks completely natural. If I were to take a photo inside this room, my camera or phone would set itself up for the light level in here, but then everything outside that I could see through to the outside environment would become all blown out. like I said, our eyes can adjust instantaneously. So basically what I saw was, with my eyes, I saw my environment look like this inside. And then when I looked outside the window, it looked perfectly natural. But the camera can't adjust. It's got to have one or the other. It can't do both unless you're doing some kind of special high dynamic range, uncompressed camera photo. And then I did exactly the same thing using a completely manual setup on my phone, right? Just sitting, I took a picture inside, good old Denny's, and the environment inside, it's kind of dark in there. They always have lights on, but you can see outside, it's pretty blown out. Now, what I did was, after I took that picture, I sat my phone near the window so it had time to adjust to the light outside. Took another picture, and you can see this is the same car. Right here, you can see the sky. You can see here are the palm fronds right there. You can see they're the same, but the one on the left where the camera is set up for the interior, the sky is completely blown out. When the camera is set up for outdoor light intensities, I have a lot of detail in the sky. I can see clouds. I can see the different gradients of blue in there. So again, when we are looking at reference, I would say 98, 99% of the time, you're going to see images where they focus on the inside. That's what's going to look good. Outside's going to get blown out. If they focus on the outside, that's going to look good, but the inside is going to be either underexposed. Well, most of the time it'll be underexposed because it's too dark. Does that make sense? It would, but that would not be usually what you see in a photo. Oh yeah, no, there are photographers who specialize in high dynamic range images that will make both look really natural. The trouble is, we're so used to seeing that contrast that it really looks weird. In fact, I was surprised, like, this is a picture on the left. That's a picture of my old house. And when we went to sell it, that we had a photographer come in and they took pictures for us, and he did high dynamic range pictures. And they had us turn the lights on in the house. We opened every window blind that we had. And when he got back and showed me the pictures, I was like, it was so light inside and you could see the detail outside. It just looked like, that's not my house. It just didn't look right. So it is possible to do that, but that's usually a very special case. Now, occasionally you will go somewhere and work in advertising where they want that effect. Great. You give the client what they want. Don't forget, Nelson, keep your mask up. Give them what they want. They're paying for it. That's an artistic decision, but we're trying to use normal everyday photographic reference to do our job. So we want to stick to what we see unless we're told otherwise. Because when you guys go to do an art test somewhere, they're going to hand you a reference image and they're going to probably say, okay, we want you to model it, want you to light it, want you to texture it, and then render it out. Or if it's a game, environment, they're going to go and then just, give us the Unreal or Unity scene so we can walk through it. Now, the deal is, when they do that, you're going to make it look like the reference they give you, because they're trying to see, can you pay attention to detail and can you give us what we want? And that's the first thing. Always be super nitpicky with detail, because adding detail adds realism. it also gives the viewer a lot to look at. The more little details that you put in, a little scratch here, a ding in the geometry there, imperfections in general really add to that realistic look. Now, you can go over the top, and you go into a lot of gaming environments and they are like way over the top. Everything is filthy, everything is dirty, but it makes for an interesting gameplay. So it's got to be a conscious decision when you do it. Okay. Questions before we head on? All right, Gitano's good. Everybody? All right. So let's take a look at an environment that's very similar to what we're going to be doing today. So ordinary average image off the internet. Let's go and just kind of browse. Now, when you guys are browsing for reference images, you're browsing for later on, browsing for textures. Make sure when you look, so for example, I'm going to put in living room. Make sure that you change the tools, or in your search parameters, you want the largest size you can get. All right, so here, this looks a little CG, but it might actually be a photo. You can see nice and bright inside, pretty blown out. You can't see the sky. You can see the bushes because they are really saturated. They're probably really dark to begin with. And that's why we can see them. Same thing here. Don't really care about what that environment looks like outside. The main focus is going to be the interior. No, that was unwanted. Oh, stop doing that. Let's get out of the add area. All right, so here, looks like we got interior, we got lights on inside, make everything look nice and bright, but again, outside, blown out. All right, so I may as well keep the search up there. All right, so going to talk through what we see in this reference image. So first off, we want to establish what is our main light source. In reality, what would it be? The sun, yeah. So what kind of light can we use for CG as a replacement for the sun? Directional, yeah. Directional's got parallel light rays. It's got those arrows. And that represents the sun really well. That is a specific sunlight effect. Those parallel light rays are like unlike any other light that we have. All the other lights kind of fan out a little bit, which really happens in the real world. So we've got directional light for the sun. That's our direct light source. So I kind of have those mapped out with these red arrows. We got direct light coming in through the window, hitting the door, hitting the walls. That comes in with a lot of energy. Now, we also have a couple of other things going on outside in our environment. Not just sunlight, but also we've got an environment that is reflecting sunlight. We've got buildings, we've got trees, we've got cars, walls, people, anything outside that has direct light from the sun hitting them, and they're visible in the window, they're probably casting some kind of bounce light into the environment. Now, one thing else to remember is the sunlight is not the only type of light that directly hits the earth. And not all the sunlight gets through directly. Some of it is diffused in the atmosphere. Remember, we've got like 5 or 6 different layers of atmosphere for that light to get through. And through each layer, some of it gets dispersed or diffused into the various gas layers. That's why when we go outside, we see that really pretty blue sky. We're looking at all the different gas layers together, ozone and, everything else that's up there. So we have that light filtering down. And then in our bottom layer of atmosphere here is where we have our cloud layer, a lot of moisture there, so it gets diffused even more. So we kind of have that blanket of light coming down. That is also streaming in through the windows. Now that's going to stream in a little differently than the sunlight. The sunlight's going to find its way, if it's at the right angle, directly in. You're going to see light rays hitting the floor, hitting the walls, and then bouncing off. But all the other light is kind of sneaking its way around in all different directions. So we're going to have light coming in, and it's going to be going all over the place. So that's all going to come pouring in through those portals. Those windows are openings that allow that environment light in. So for that environment outside, we would wind up using a dome light. That's going to give us a couple of things. One is it's going to give us a light source outside that is meant to replicate the sky. And we're going to put an image in it, a high dynamic range image that has enough information that we can also use it for color information as well as light intensity to come in. So that's going to give us our environment. That's going to add in some color. That's going to add in some diffuse light. Now, when we have a small environment, we put a dome light around it, right? The dome light's just going to surround our model with light in all directions. Nice, even, diffuse light, very soft light. But the problem is, it doesn't make sense if we are inside rendering a still life or rendering a long shot in our environment. Doesn't make sense to calculate 360 degrees of light when we only get the benefit of a couple of windows. So for those windows, what we're going to use instead is basically going to be something called a portal light. So a portal light allows us to take all that dome light energy and funnel it into a smaller area. Once we create a dome light once we create a portal light inside a dome light, the rest of the dome light pretty much shuts itself off. And it takes all the energy and light and color and puts it in through the portal. You can have as many portals as you need, and that dome light, based on the location of those portals, it will pick up the image from the dome and show it to you. So it's a lot more efficient to calculate those few small openings than 360 degrees. And we wind up with slightly less noise when we go to render too, because it's a smaller area of indirect light. All right, does that make sense? Did I lose anybody? Questions? All right, no questions. All right, Julio, you good?
Good.
Okay. All right, now, one thing we can always count on is that we do not get a one-to-one energy transfer in CG like we do in the real world. So that means when we've got sunlight coming in, hitting our environment, we are basically not going to get as much energy bouncing off of the floor, the walls, wherever it happens to hit, as we would in the real world. So we need to add an additional light, and usually a light that makes a very good candidate for that kind of bounce light is an area light, because an area light is going to be diffused. And usually when you've got, sunlight hitting a wall or hitting a floor, once that light bounces off the wall or floor, it's going to be diffused because it's going to have small irregularities all over the place. So bounce lights, we can shape them, using area lights. We've got rectangles, squares, discs, pretty much any shape we would need. And what we would wind up doing is adding in a couple of those lights. We change colors here. So might wind up adding in a light here, because we would probably get some energy bouncing off this door, but probably not to the point where it would blow out the wall like that. So we add an extra light there, might add another one here, might even add one on the floor, just so we can start to, add a little additional light and life into the environment. Like I said, we will run out of energy really quick. By the time the sunlight bounces off the door under the wall, it's probably going to be about 60, 70% weaker than in the real world. So we always add in some extra lights. Walls, floors, ceilings, area lights, perfect for bouncing light around. All right, nighttime, little different story. We don't have as much energy coming in from the outside. We still may have a little bit of low-level light coming in from an outdoor environment. There might be light, they call it light pollution from parking lots, densely populated areas where everybody's got a light on. Cities always have lots of lights on. But that's still going to represent a very small amount of light coming in to the environment. So we would still use a dome light. We would still use a high dynamic range image, but we would have a nighttime image in there and try to match the appropriate kind of light. If we turned all the lights off, one of those deals where you probably wind up stubbing your toe in the dark because the light really just falls off really quickly about 10 feet away from the window. Most of the lights that we encounter at night or inside come from artificial light sources. And those are perfect for mesh lights because we can take lights, if they've been modeled correctly, they will have bulbs in each light. We'll be able to take those bulbs, turn them into mesh lights, and be able to have them in position in our environment and, make it look kind of natural. So what is the main light source going on in here? What's that? Okay, but which one? Where's it coming from? Which one? Okay, so we got this one here. All right, so this looks like a typical lampshade where you've got light coming out the bottom. You've also got light coming out the top. So you can see we've got light on the ceiling. We've got light, kind of a nice big shape here. And that's providing most of the light. And that dome light outside the windows there, that's really just visual eye candy. It's really not there to provide a lot of practical light in the environment, just visual. Now, there is there is at least one other light in here. Yeah. Yeah, one in the corner by the TV here. Now, chances are that's probably a lamp. Yep, Gaetano, there is one right there. There probably is a lamp that looks like somebody might have even taken the shade off the lamp, put it behind that entertainment center here. Just enough to make it visually interesting and kind of separate, the end of the environment from outside the window. Because without that light, that whole entertainment area, that would just bleed right into outside. So just a little bit of extra light in there kind of helps to define the environment a little bit better. So that could be another light if it's been modeled already. If not, what kind of light could we use there? We could use a spotlight here. Yeah, we could also use a point light, because chances are there's some kind of light there. It's probably a bare light bulb. So if it's a bare light bulb, it's going to shine 360. Point light would work out pretty good for that. But yeah, you might be able to get away with a spotlight. Might be able to get away with an area light, although that looks a little more direct. It doesn't look as soft as an area light. But probably, I always go for, if I think it's a bare light bulb, I go for point light automatically, because that's really the one that represents a point light the best, because it shines in all directions. All right, good. All right, so exterior. Exterior, we have no walls generally. We have no roof. So it's a fairly open environment. So in exterior environments, we have pretty much a dome light with an image in it to represent our environment. We have the sun, which if the sun is out, we have a directional light. If it's an overcast day, we don't need the sun, but we're still going to need a pretty bright dome light. So I have a couple of renders here that I did. One on the bottom here is 10:30 a.m. The one on the upper right, that is at 2 p.m. The shadows are very similar from the sun. Notice they are not super soft. That's why for sunlight, we recommend turning the angle, which softens the shadows, to 0.5. That is pretty much average sunlight softness. The longer the light is, the softer it'll be. The shorter the shadows are, the harder those shadows will look. All right, now, one of our environments that you're going to be doing is the exterior scene. And this is what they call here at Full Sail the Zen Garden. And this is behind building 4D, Delta. 4D. So if you come out the back, go through the back lot, go over the bridge, go around. You guys probably know where the back way to 4B is by now. Do you guys have anything in 4B? Bravo, 4 Bravo? No? That's the animation 3D arts building. If you keep going around there, there is an area that's set up it's a really nice space. So we decided to take photos of it, and your lab instructor, Frank, modeled it for us. So that is going to be our exterior scene. So if anybody wants to take a look at the actual environment, I highly recommend it. We provide you with photo reference as well as CG reference for the lighting. So you can see where we got the lighting from and then where we got the environment from. It's really going to help out when we start doing materials and textures to take a walk back there and go look at it. So the reason I mention that is because both of these, this one was done. This is 4D. This is the Zen Garden. This is 3D Arts, which is for Bravo. All right, so shadows, very important to pay attention to. For the interior, they're going to come from the sun, usually, or from the sky. If there's no sun and it's really overcast, they're going to be super soft shadows, but they are going to come from the environment outside. So here, time of day, you can see this is sunlight. This is about 6:30 in August. So the sun's pretty low. It's still pretty bright out. And the shadows, even though they are pretty long, are not super blurry. They're not super soft. As we get towards dusk and nighttime, the sun gets lower and lower in the sky. When the sun gets low enough, we're going to have very little bounce light in our environment. We're going to have a lot of light in the sky, which is going to produce a lot of backlight. And it's actually still visible if you go outside, even when the sun is down at night. Go outside at night, take a look at the sky. The sky is always going to be a lot lighter than the environment you are in, especially, around here. Now, if you're out, way out somewhere away from cities and, it's not a densely populated area, the sky might be a little darker, but it's still going to be, in general, a lot lighter than the environment you're in. Go outside, you'll see lighter sky, you'll see shadows of trees and buildings, backlight, basically. Very dim backlight. Very little indirect or bounce light. Now, when we get to full-blown nighttime outside, we're going to be using a lot of artificial lights. We still will have a dome light. We'll still have an image inside the dome light to provide environment and color, but that's not going to add a lot of light. All the light's going to come from indirect light sources. So when you have something like this, where you've got an environment, you're going to have a lot of small lights rather than a couple of big giant lights. Now, if it's industrial, like a parking lot or a stadium event, well, obviously they're going to be super bright mega lights. It's going to look like daytime in there. But it's still artificial lighting. Does that make sense? Questions? All right, so inside our lesson 5 activity, there's a link to the color temperature chart by Jeremy Byrne. If you don't read anything at all, at least read chapter 8, The Art and Science of Color, because it's a really good chapter. Jeremy Byrne is a lighting TD at, well, he was at Pixar. He's done DreamWorks. He's done ImageWorks. He's done a lot of stuff. He also does a lot of writing and videos. And his big thing was color. So he spends a good, bit of information here talking about warm versus cool and how color, looks in the real world and how we translate it into CG. So he's got these color temperature charts that are inside there. And this one happens to be the source with the corresponding temperature in Kelvin. which is how we measure color temperature. And he's also got the appropriate Kelvin to either RGB 0 to 1 or RGB 0 to 255, depending on your color profile. So right down here, art and science of color. Got a couple of things: shading surfaces, color temperature chart, LED color temperature chart. Here's a kind of a sneak peek for project 6 on the standard or the Arnold standard surface. And if you haven't taken a look at Arnold's like help docs or their tutorials, they actually have some pretty good stuff in their guides. And one of them is they've actually got all the attributes inside the AI standard surface, and they've got what each attribute does, and they've got small little thumbnail renders under it. So you can see exactly what the different attributes do. All right, now, anybody know why we measure color temperature in Kelvin? All right, fair enough. Not usually something you get a lot about unless you're in physics. Kelvin was an 18th century physicist, and he found when he heated a block of carbon that it glowed different colors at different temperatures. The hotter the carbon glowed, the cooler the temperature got. The cooler, the warmer the color looked, which is kind of reverse to what you think. We always think cool as being cold, but it kind of works the same way a star does. There are different stars. There are red stars. There are blue stars. Ours is kind of a whitish star. It's like midlife, somewhere in there. But very young stars start out as being very red. And then as they get older, their color or their temperature increases and their color changes. So our star is, kind of midlife. And then as stars get older, you probably have heard blue dwarf or blue giant stars. And those are older stars that are starting to go towards the end of life. They go burn hotter and hotter and hotter till they reach the point where they go supernova, and then they just explode. And all that matter goes out, and I guess somewhere else, some other star will form somewhere. But as he was heating these blocks of carbon, he started to write down the colors and what they looked like at the different temperatures. So Jeremy Byrne kind of just took everyday objects and translated them into what the different color temperatures look like. So match flame, 17 to 1800, that's going to be the reddish part of the flame. And if anybody's, ever seen a flame on a match or on a candle, you know that it's got red, it's got white, and it's got blue in there, right? The blue is the hottest part of the flame. So all of our artificial lights fall down into right around this area. So where this would be the warmer stuff. And you get into probably around here, this would be whitish. And then down here, this would be cooler. So as the temperature increases, the light gets cooler looking, bluish in color. Really important if you're trying to match what lights look like. If anybody ever goes out, you buy a package of light bulbs or you buy one bulb somewhere, you look on the package, it's going to show you how bright it is in lumens and also what the color temperature is. Is it warm? Is it cool? is it warm white or cool white? And, there are various things. Usually light bulbs are somewhere between like 3,500 and 4,500, maybe 5,000 degrees. All right, so all of that, we're just kind of trying to build a foundation for when we actually start using these features in our environments. All right, so dome lights, very simple. In fact, let me fire up Maya. We'll do a quick demo on it. Dome lights, portal lights, mesh lights, all are created inside the Arnold shelf, just like the Arnold area light. You're only going to get to it from the Arnold shelf. Now, obviously you can go into the Arnold menu, but that's just another pull down and another menu when you can just click on an icon. Now, if you hover above the area, you can see there's our create sky dome light. That's our dome light. That is a portal. Those are the two we're going to be using. There's photometric lighting, but we're not going to do photometric lighting. There is the mesh light. So these three are going to be your friends. Sky dome or just dome lights. Portal lights don't work by themselves. They only work if you've got a dome light inside your environment. So you have to have the dome light. That has to be selected before you create the portal so it knows where to attach itself to. So those are the three we're really going to be interested in for this part. All right, so let me just create a simple plain couple of spheres in there and just kind of show you what this stuff does. So let's translate that up 1 unit. Let's duplicate it. And just like any scene, when we start, we need to assign an AI standard surface to it. So AI standard surface. There we go. First thing we're going to do is turn off the spec. And for this, normally we would throw the color value down to 0.5. Today we're going to be changing that up just a little, but 0.5 is good for now. It's fairly neutral. So if I try to render this out in Arnold, I should not have any lights. I don't have anything visible. Now, if I just click this dome light button and hit render, this is what I get. I get a 360-degree dome of super soft light with a default intensity of 1, and the color is automatically going to be white by itself. So I can adjust the intensity. You can go as low as you want. I don't like the slider. It's really it's way too quirky for it. And you can go well above 1. Got to be careful though. You wind up looking like you're trying to take an Antarctic picture during the day in a blizzard. All right, now for color temperature, I mean, normally what we've been doing up to this point is using the color attribute. Oh, and by the way, this is what the dome light looks like if we zoom all the way out. So it is meant to be pretty much an infinite light, infinitely far away. Whatever size your environment is, when you hit that dome light, it's going to size itself to completely surround your scene or whatever you have in your scene. Good enough. So let's turn on color temperature. Let me keep this so we can compare what they look like. All right, so just turning on color temperature, notice that it took on a slightly warmer color. That's 6,500 degrees. That's basically daytime, noon, pretty clear sky, pretty whitish light. But you can honestly see that is not really super white. Now, as I start to lower this, and by the way, don't use a slider because color temperature usually jumps in increments of about 500. Whenever you go look, you see 3,000, 3,500. You might see 3,800, but generally it's going to be in pretty big chunks. So usually I just recommend when you're starting out, just start in 500 block units. Like start to lower it. So let's see what 6K looks like, 6,000. All right, so you can see it's getting slightly warmer. This is 6,500, that's 6,000. Go down to 55, we're getting warmer still. Go down to 5,000. Now we're really starting to warm up quite a bit. Go down around 4,500. Well, not 45, 4,500. You can see what happens when you go really low. So now we're going to start to get into almost artificial light color. So 4,500. $4,000. Let's try 3,000. 3,000. There we go. 2,500. You can see the lower we go, the warmer it's going to be. Now, the opposite is true when we start going above 6,500. So start going up to 7,000. 7,500. Starting to get a little warmer, or sorry, a little cooler. Get up to around 10,000. And now you're really, really cool. So the color, the hue is adjusted. Basically, it's the hue is adjusted by the color temperature. And the saturation is always going to be kind of minimal unless you start getting into the real extremes. Like I said, 6,500 is kind of a neutral day. All right, that kind of makes sense. Pretty simple concept. Now, as far as adding an image, we'll get into that when I do demo for the interior or the exterior, because that relies on you having the image and having your project set properly. And I don't want to do this since this is just kind of a throwaway. The one thing I do want to take a look at is, while we're here, and we'll get into portals also when we go inside, because it doesn't make sense for me to do it in a bare open area. But what I do want to show is how you make mesh lights. So mesh lights are actually very simple, but there's a couple things to keep in mind. So let me turn down my dome. Let's go down even more. And let's turn one of these spheres into a light. Which one? All right, left one. So I select the left one. This is the order of operation. You got to select the geometry, then go up and turn it into a mesh light. And let's watch what happens. So right now, this piece of geometry has an AI standard surface assigned to it, so it reflects light. That's what the AI standard does. Hey, I reflect light or I let light through. So when I create, stop doing that. No, stop. When I do mesh, which is this icon right here, notice that all of a sudden it parented something inside my sphere. It basically gave it a light attribute in there. So now this is telling the renderer, this surface no longer reflects light, this surface emits light. So now, by default, if I hit the render button, notice it looks like that surface disappears. And you might say, oh, okay, well, that's probably because it's not bright enough. So here are my mesh light attributes. Fair enough. So let's crank it up. Let's crank it up even more. There we go. But where is it? How come I can see it in my viewport, but I can't see it in my render? That's because by default, it is invisible to the camera, which kind of doesn't make sense to me. Like if you have a mesh light, the reason you're making it a mesh light is because you want it to be visible. I see bare light bulbs, I see light bulbs. I want to be able to see the light inside there. So just be aware that when you create a mesh light, you actually need to turn this little box on. Make sure you turn on light is visible. Without it, we can't see anything. Nothing. Once I enable it, now it becomes visible to the camera. Now, when I move it around, it works. Does that make sense? Questions? AJ, Gaetano, Julio, anybody got questions out there in Zoom?
Good.
Okay. Good. Gaetano's good. Thank you. All right, now. Suppose I go, oh, that wasn't the mesh I wanted to make into a light. I screwed up. What do? All right, well, first thing you can do is you can actually delete that light that is parented to the geometry. So if I delete that, now I'm still left with my sphere. And if I hit the render button again, now it reverts back to its former self as being a reflective surface. Does that make sense? So the good news is if you accidentally assign a mesh light to the wrong surface, it's easy to undo. All right, so here's a bit of a quirk about mesh lights in Arnold. Suppose you want to take a couple of spheres, two of the spheres, say I'll take the two outer ones, and I want to make both of those into a mesh light, but I only want one control. Why? Well, I'm going to assume like all the lights we have in the ceiling here in this room, they are pretty much the same intensity. They're the same light type. The bulbs are probably all about the same age. And we also have a single control for those on the wall. Wouldn't that be a better idea than having individual controls for lights that are the same? You'd want to have them all grouped under one. So in order to do that, you would think you can just, well, I'm going to command select both of these meshes. Well, actually, I can shift select because I'm not in the outliner, and it doesn't matter what order I select them in. So I have those two. And, you know, a reasonable person would assume, great, I select both of those. Can I just hit the create mesh light button? It'll make both of those a mesh light with just one light control. So if I do that, notice what it did. It took the very last one that I selected and turned it into a mesh light. But it didn't, it completely ignored my first selection. All right, so let me go back. Let's get rid of that. Let me do it one more time. Well, let's select this one. Let's select that one. Let's create a mesh light. So it did the opposite. It took it did the same thing. It took the very first selection, made that into a mesh, and ignored the second selection. So if you want more than one object to be controlled by the same light, we need to basically combine those two together, and then Arnold will treat it as one mesh. Why is that important? Because in the interior, we've got a bunch of recessed bulbs in the ceiling at night, and there's 18 of them. Instead of having 18 controls, what you want to do is select all the light bulbs, combine those meshes together, assign one Arnold mesh light to it, and now you control all those bulbs with a single light control. Just like we have pretty much one slider to control all these track lights in the ceiling. Does that make sense? So to do that, sounds complicated, but it's really not. You select both meshes. Make sure you're in the modeling tool set. Go up to mesh. Combine. Now you've got a brand new shape. Make that into a mesh. And now when I render, notice I've got two bulbs. Yes. Say that again. No, it doesn't recognize a group. It's still, what it does is it recognizes one, I guess, whatever the first object in that group is. It might not, to be honest, I've never done a group. Let's try it. If it does what I think it'll do, I won't be surprised. It does. So let me Z back here. All right, so let's select both those. Ooh, that's scary. All right, let's close that. Okay, yeah. Whenever you get weirdness in Maya or Arnold, just close the render view, stop it, open it up again, re-render. All right, so let's group it together. So it's grouped. Yep. So basically we selected a transform node and not a mesh. So the other question usually comes down to, what happens if I parent one of those lights to the other light? So I should be able to just middle mouse click, drag it, drop it inside there. So now they're both parented together. What happens if I do that? Well, it only respects one of them, probably the top node in the chain. So let's Z back. So like I said, the best way to do it is mesh, combine. Now both are combined into a single mesh. Let's render it out. Well, first, I got to create a mesh light from them. I need to make it visible. Don't forget to make them visible. And then give it some actual intensity. So let me select my dome light. Let's turn that off. There we go. All right, so that's a little quirk about mesh lights you need to know about. The fact that if you want to control more than one object with a single mesh light, which it makes sense for similar lights in a group, say an arm lamp, they're all going to have the same light, the same bulb, the same intensity, same wattage in theory, same age. Be silly to have separate controls for each one of those bulbs. You'd want the whole lamp to be controlled by one mesh. And that's why we need to combine it. All right, so that's kind of a quick mesh light tutorial. Little bit of a quick dome light minus the image, which we'll get into. And let's see, what else can we do? Oh, all right, this is pretty good. So let's talk a little bit about the images we're going to be putting into the dome lights. So if anybody paid attention to project 1, where we had that visible during the day, if anybody did a render where you could see outside the window, we had an environment out there. And that was basically our Zen garden. Because we went out and we have an HDR camera. We went out and made an HDR from it. But an HDR image is a high dynamic range image that allows us to have enough information in that image to be able to use it for lighting and also as color in our dome lights. So if you remember the first day of lecture, we talked about images you get off the internet. So typical like PNGs, JPGs, well, most Targas. Let's see, those are the common formats. Well, TIFF is one of them also. All right, those are traditionally what are called 24-bit RGB images. Right? Each color, red, green, blue, has 8 bits of information. So 8 times 3, or 8 plus 8 plus 8 equals 24. Each channel, 8 bits, is equal to roughly 256 shades between absolute white or absolute black and absolute white. All right, HDR images are what we call 32-bit images. But that could be a little misleading. You would think, okay, isn't that just like having another channel, like red, green, blue, and you throw an alpha channel in there, doesn't that make it 32? Yes, it does. But high dynamic range images have 32 bits of information per channel. And you are not limited to just 2 or 3 or 4 or 5 channels inside that image. You're basically limited to the file size that you can handle. So they can be massive. That's why these images are used for compositing. They're used for, well, not just images, but all the frames that are generated in digital cameras are all high dynamic range images. So they can keep as much information as they can so that they can basically recreate an environment if they need to, based on lighting, light information, color information, intensity, pretty much whatever they need. 32 bits per channel. So if we have 256, let's just for fun. So 256. No. It's not going to be squared. It's not going to be cubed. It's going to be 256. So yeah, that's roughly 4,298,967,296 bits of information per channel. So you're talking about billions of bits of information. That's why they make perfect, well, image lights, lighting images. All right, so basically the original HDRs were constructed by taking multiple images or multiple photos of an environment, of an object, whatever it happened to be, with different levels of exposure. So what they would do is they would go outside, take a picture of an environment with normal exposure. Then they would go out and underexpose it, make it look like it was super dark because they're looking for the shadow detail. Then they would go in and overexpose it because they're basically looking for the brightest points that are there, and combine those three, usually a bare minimum of 3 images together, so that you had basically all of that information in one image. You had a normal looking image, you had a lot of, you could really see detail in the shadows, and you could see, well, have detail and information in the brights that would normally be just white or blown out. Now, it's really an advanced form of imagery, and it was started back in the mid-1980s with NASA research universities who were doing imagery research, government, satellite imagery, basically to try and have as much detail as they could, especially with NASA, where they go up, very expensive to take pictures in space, send them back, and they wanted to have a format that would capture as much information as they could and give them as much detail. But it did not become accessible to us, the consumer, until we broke the 1 megapixel barrier on our digital cameras. Because all of our camera sensors, up until I would say the mid 1990s, were pretty garbagey. If anybody's ever seen very, very early digital pictures, they were really small and really grainy or pixelated looking, because the sensors themselves couldn't handle that much information. But now we're up to 8K, 10K sensors in our cameras, and we can definitely handle pretty much anything. So now high dynamic range imagery is actually commonplace to us. A lot of streaming services are offering HDR products, shows, movies, games coming around too. The next generation, especially with all the stuff that's been done in Unreal Engine 5, their whole global illumination and no limit polygon count in their environments is all thanks to, being able to handle big, gigantic image files. So give you an idea, this was originally coded in the C language, which is kind of like the modern day mother of all languages we have now. Python, C++, C#, Maya's embedded languages based on C++. Python is the biggest one because almost every software package that you have has some kind of Python interface. Python is a scripting language that lets you basically create automated features. You can write interfaces, you can write modules for the program. In fact, RenderMan's last version before we left using RenderMan to go to Arnold was all written in Python. It wasn't a dot bundle on the Mac, it was a .py file. So they had Python basically running everything. All right, but I digress. So there are two common formats for HDR images. The original and still most popular on the web is .hdr. That is the original format. The trouble with that was it wasn't as flexible as people in film needed it to be. It really wasn't friendly to write and alter the code of it in an easy way. So I'd say late 1980s, early 1990s, into the mid 1990s, when Industrial Light and Magic started playing around with this stuff, they started to develop their own version of it called an EXR file. And by the time 2000 rolled around, they were ready to launch it into production use. And the reason 2000 was a big deal was not because of the Y2K bug that everybody heard about, I'm sure, but it was mostly because of the reboot of Star Wars. Episode 1, not Jar Jar Binks. It was because Sony had the first digital high dynamic range production camera. Instead of film, George Lucas decided to go full digital. ILM realized, you know what, this is a 2K digital camera. And at the time, 2K was a big deal. Everybody's like, 2K, hi, I got that on my phone, my old phone. But the deal was, in those days, 2K was pretty good for a production cinema camera. And they realized that they needed flexibility to be able to write all the different things they wanted to capture with this camera at the same time. Be able to write them into separate areas in the film or in the digital file. So basically, they came up with this EXR format, and they decided to make it open source. You guys know what open source is, right? Open source, free to use, as long as you, if you alter it, contribute it back to the community. Free to use, free to alter, free to distribute, but you must, if you make changes to it, supply it back to the community. So they decided to do that, and everybody decided, hey, this is a great idea, let's use it. So it has pretty much become a standard because it is free. Pretty much every software package, as you guys saw, including Unreal and even Unity, use EXR output. It's really the way to go for high quality images and cutscenes or cinematics. All right, there are two kinds of choices that you have with EXR. Well, actually more HDR than EXR. So this format you will see as HDR or EXR. This one is usually HDR only. And these are much older. They are called light probes. It basically look like somebody took a picture of a mirror ball in a garden. Now, why they were so popular early on, I'm not really sure. Most modern renderers are starting to not support this type of HDR image in dome lights. Arnold does. Arnold supports both of these, but this is the preferred one. If you ever work with RenderMan, this is the only kind RenderMan will use. If you ever work with V-Ray, V-Ray prefers this. You can find Angular, but you really got to go hunting around for it. Like I said, these have pretty much fallen out of favor. So if you see these on the internet, and you know they're free usually because nobody wants them, and also they are usually around 2K. The HDR stuff, or the that square rectangular version of the image, either EXR or HDR, you can get those up to 8K, 10K. In fact, today we're going to send you to pick up a couple of HDR images from a website called HDRI Hub. They have a couple, the areas I'm sending you to are free. And you can get a free, they say it's an 8K image, but when you download it, it's about 5K. But for free, it's a good deal, especially as a student. And free non-commercial means you can go out and make money with it, as long as you read and understand what you're doing with it. So, does that make sense so far? Any questions? All right, this is a pretty good time to take a break because when we come back, we'll go over what you guys are going to work on today. The good news is this isn't going to be due till Sunday, so you get a couple days to work on it. Normally, if this shows up in the middle of the week, if we didn't have early Monday off, this would be on Wednesday and it would be due Thursday. But you guys get an extra day, so enjoy it. Take advantage of it. When I come back, we'll do demo for interior, exterior. We'll go over all the requirements. I'll show you where the docs are for this stuff, where to go to get the images. Pretty much, I'll try and steer you away from any pitfalls that you might run into. All right, so any questions before we break? Everybody good? Questions? Julio, Gaetano, AJ, questions?
No, sir.
All right. All right, Gaetano's good. So let's see. Is it 34? So let's come back at come back at 257. We'll pick up. Oddly specific. All right, so I see you guys back here in about 20 minutes. I'll render out the first part of lecture and we'll pick up.